number of years for your investment, okay? And n, this is the last one. Little n is t times m. You see, number of periods in a year and times number of years. So this is the same as what the number of total number of compounding periods. So for example, somebody is investing money quarterly for 3 years. So they are going to receive interest 4 times a year for 3 years. So interest, you are going to receive interest how many times? 12 times. That is the meaning of n. Okay? I know there are quite a few, but I'm sure you can handle that. Okay? So these things you are not going to mix with anything else. Okay, and this is a little n, this is a little m. So I want you to be careful about. Okay? So here we go. Example 1. Oh, even before that, the formulas. Yes. Okay. How do you compute? Compute? Okay, earlier I said you are going to add interest and you are going to have a future value, correct? So how we are going to compute the interest? Well, compute the f, future value. Future value is 1 plus I to the n times p. Okay, so this is a formula. So what is little I? We did earlier, little I is little r divided by m. What is a little n? N is m times p. Yeah, so as you read, you need to break down everything before you put it in the formula, okay? And sometimes you want to compute for this present value. So how you are going to find the present value? We divide both sides by 1 plus I to the n. So in short, p equals f divided by 1 plus I to the n. Yeah, of course you can say 1 over 1 plus I to the n times f. Okay? So when you want to compute the future value is always more than present value, right? So 1 plus I to the n, this is larger than 1, so it's going to be like a multiply factor. On the other hand, when you compute this present value, always the present value is less than future value, therefore you are going to divide this future value by the same thing over here. Okay, so this is a formula. Okay. So I'm going to put it up here. F equals 1 plus I to the n times p, and p equals f divided by 1 plus I to the n. All right. We can look up anytime. Okay. And example 1. $5,000 is invested at 8%. Invested at 8%. They didn't say anything about 8%. That means 8%. This is per year, okay? Per year. That is always implied when you see bank statement, everything. Compounded quarterly for 3 years, okay? Compounded quarterly for 3 years. So let's pick the numbers or symbols that we need. 5,000, yes, that is P. Okay, I'm going to mark this one as a P. 8%, so this is a little r. And compounded quarterly, so that is M equals 4. Okay, for 3 years, therefore T equals 3. Did you get that? So Look at this. What do we need for this formula? We need I. How do you compute I? Yeah, interest rate for the whole year divided by 4, so that you have 4 equal parts of this interest rate for a whole year. Okay? So divided by M. So that is 8%, 0.08 divided by 4, that gives you 0.02. So again, your understanding is you are going to receive 2% of interest in each quarter. Okay, in each quarter. That's what that means. And what is that? The N? N is number of years times each year you are going to have M periods. So for 3 years and each year you are going to have 4 periods, therefore 12. So that means you are going to receive interest 12 times. That's what that means. Okay? Or if you make a payment, turn the table so that you borrow the money to buy your car or something, to buy a computer, whatever the reason is, n equals 12, that means you are going to make 12 payments. Okay? For this one, yes. Okay, here. Alright. So once it's done, okay. So what is that? We compute future value. So 5,000. 1 plus 0.02 to the what power? Yes, 12 power. Yeah, I put P first, okay? Doesn't matter, of course, right? Okay, when you do this, I literally write this, but for your calculator purpose, okay? Calculator purpose, what is best? 5,000 times, yeah, you can do this one in your head. This is 1.02. And then make a power of 12. If you put it this way, times, okay, times and this, or let's say, okay, times this, that means the power is only applied to 1.02. So that makes like less use of parentheses. If you skip parentheses, it's going to, either you are going to have a very wrong answer, or it's going to give you a syntax error, okay, so you waste time. So I want you to compute this and then do this, okay? So how much is that? 5,000 times 1.02 to the what power? 12 power, so that gives you $6,341.21. Yeah, when you talk about money, you are going to go talk about cents, right? Up to cents. So final answer is $6,341.21. Okay, so round to the hundredth places or 2 decimal places. Okay, so this is the final answer. Okay. All the problems, yes, we are going to, as you read, we indicate what this is for, and ultimately we compute I and N, and then put in the formula. Okay, so today's work, that is going to be enough for that. Okay, now computing present value in the second problem. Example 2. Computing the present value. Okay. How much money must be deposited now in order to have $8,000 after 5 years if interest is paid at a 6% compounded monthly? Alright, did you digest all? Okay. How much money must be deposited? So we do not know. Okay, present value, this is in question mark. Over how many year period? Over 5-year period. Okay, anyhow, your goal is you want to have $8,000. Okay, 6% compounded monthly. So let's summarize what is what. Okay. What is what? 6%, this is R monthly, therefore M equals 12. What is this? That means T equals 5. Correct? Okay? And of course this is F. This is what we have. So let's compute I and N. Always, yes, you need what you see what you need, okay? So I equals R over M. R is 0.06 divided by 12. 0.005. So in other words, this is half percent per month. That's what that is. Yeah, that's why half percent per month, therefore whole year 6%. Okay? And what is n? Little n is t times m, so t times m. So for how many years? 5 years. Monthly is 12, therefore 60 times. So in other words, you are going to receive interest 60 times. But anyhow, how much you must deposit in the beginning so that you have $8,000 in 5 years, in short. Okay? So this is what you have, and we are going to put it in the calculator over here. So what is that? F is 8,000. 1 plus I is 0.005, 0.005 to the what power? 60th power. Okay, so calculate this. 8,000 divided by 1.005. This much you can do in your head, right? To the 60th power. So, see, on your calculator, yes, 8,000 divided by 1.005 to the 60th power, then you can avoid all these parentheses, okay? Because the power is applied to only this and then divide this. So how much you have? 5,000 compounded monthly. Yeah, compounded monthly. So that's correct. So that gives you $5,930 and 977. So 98 cents. Okay. So this is a solution. Okay. So now the mystery is over. How much do you have to put in there in the beginning? Yes. If you put $5,930 and 98 cents, and then put the money in, leave it in the bank for 5 years. Under this condition, money will grow to $8,000. Okay? All right. I didn't ask over here, and then, but I'm going to add this part. Okay? How much interest do you earn? Okay? How much interest do you earn? So interest earned. Of course, what? In 5 years. Okay? So what is it? Interest. Interest is the one that makes difference between this and this. Okay? So 8,000 minus $5,930 and 98 cents. Okay, how much is that? 8,000. Subtract. Oh, I'm sorry. 8,000 subtract 593098. So that is $2,069.02. This much you are going to earn. Well, that is a very, very generous amount of interest you are going to earn. Well, yes, really, because we started with the 6%. Right now, how much the bank is going to pay you? Very, very little. Very, very little, like a 1%, 1.2%. Yeah, like that. Okay, very little. So what you see in the book, do not take it as a norm, okay? Please don't. These numbers are just, I didn't want to bother you too much with those just small numbers, okay? Rather, just a little simpler numbers, but the concept you understand. So that's why I did it. All right. The next one concept is effective rate of interest. Okay, effective rate of interest. Well, when you see advertisement from bank, they are going to say annual percentage yield, APY, everything is in the book, okay? Annual percentage yield, annual percentage yield. Yeah, that's the language they are going to use. Alright, so what's the concept? Okay, so this is a scenario. So let's say I do not have any formal education about this compound interest, how to compute. Even if you learned many years later, you may forget, right? Okay, so you don't have much of a concept of a compound interest. But you have money, okay? So you go to the bank, sit down with the bank teller, okay? Or those, bank employees, and then you ask, well, which one is better? It's like if you offer me 4% at compounded interest for quarterly, or a little less interest but is the compounded monthly, which is a better investment? And the banker is going to start to explain. So I said, no, I'm sorry, I cannot really understand and I cannot really compute those things, but I understand the simple interest concept. So can you convert that one for simple interest concept? And by the way, this effective rate of interest is only for 1 year, okay? Only for 1 year investment, not for multi-year investment, okay? So what is going to be is like, okay? So I can understand only simple interest. So tell me, just in a straightforward way that if you invest in this case that is equivalent to 5.2% the simple interest. I understand that concept, okay? That's where we use it, okay? So what is the formula for effective rate of interest? That is, first of all, REFF, interest rate of effective interest rate is 1 plus I to the m minus 1. Okay, you remember? Yeah, throughout the chapter, whenever you see little I is always the same thing, same meaning, and the little m also. This is a formula. Okay, so how many times you are going to receive interest if you invest in compound interest? Okay, so just change it to. So convert compound interest to simple interest. So everybody can understand better. So that is the meaning of effective rate of interest. And another way of using is number 2 is compare different options. Okay, it's difficult to compare, okay, because a little higher interest rate but a little lower interest period, okay. So those are kind of mix match, and how we are going to compare. In that case, use effective rate of interest, and then you can compare straight. Okay. So number 3, example 3, yes, compare 2 interest rates. Plus I to the m minus 1. Okay. So example 3. Calculate and compare the effective rate of interest for savings accounts paying A. One option is a nominal rate of 3.65% compounded quarterly. Okay, compounded, quarterly. Option B is nominal rate. Nominal rate is the rate they announce. Okay, so that is 3.6% compounded monthly. So you see, this one is a tad bit higher rate, but this is less often. More often, but tad bit lower interest. So we cannot really tell what is a better option. So in order to do that, we are going to compute this. Okay, so here we go. What is 3.65%? Yes, that is R. Okay, R is 3.65%, so therefore 0.0365. And the quarterly, so M equals 4, correct? So what is I? R over M. So you compute that. The computation goes, that is 0.009125. Yeah, the more digits you keep, is going to be more accurate. Okay? And the My Math Lab is going to tell you sometimes it's just do not round off anything. Okay, just put it in directly into the calculator. Okay, and the other one here is R equals 0.036, M equals 12, correct? So what is I? That is 0.036 divided by 12, that is 0.003. Okay? So, calculate that. Okay, so A gives you the effective rate of 1 plus 0.009125 to the fourth power minus 1, which is 0.037. Okay? On the other hand, the next one is 1 plus 0.003 to the 12th power minus 1. Yeah, that gives you 0.0365999. So I would say 0.036. So what does that mean? 366, okay? So that gives you, this is roughly 3.7%. That is equivalent to saying that, hey, you are going to have a 3.7% interest rate converted to simple interest. This one is 3.66%. So therefore, which one is a better option? Yes, of course, this is a better option. Okay? So again, your answer is going to be slightly higher than this compounding interest rate because it's compounding. And this is, when you convert that, this is the same as like if I put in a simple interest rate, this is the same percentage. But anyhow, for this answer, yes, this is a better option. Okay. And the simple interest. Yeah. Earlier, I introduced the concept of the simple interest. The formula is F equals 1 plus Rn times P. As you see, there is no power. There is an exponent, that means it's compounding. No compounding effect, therefore no power over here. R and N is the same as before. Yeah, we never used R directly into the formula, but for the simple interest is always per year. Okay, per year. And that. Okay. N is here. It is going